Hey guys, welcome back to day 6 out of an code in C++. So in today's question, it's a graph question. We get given a grid like this. Let's look in the IDE. And yeah, you start on this pointy caret thing, and then you're facing up direction, and you want to keep following that direction until you hit a hashtag. And then whenever you hit a hashtag, you want to change 90 degrees or clockwise. And then you keep going, hit a hashtag, keep going, you turn right, keep going, turn 90 degrees again, 90 degrees again, 90 degrees again, 90 degrees again, and then you keep going pretty much until you exit the map. And then you just want to count how many squares you've touched. So yeah, it's a pretty standard graph traversal question. So looking at the main function, firstly, just process the input, and I converted the initial input into a 2D vector where essentially 0 represents empty square, a 1 represents a blockage, and then I kept a third value, -1, which keeps track of the squares we've already visited. So yeah, when I just processed the initial input, converted the hashtags into ones, and then I kept track of the starting coordinates. After that, I just did this DFS function, and what this does is that we just traverse through the array doing the rules I said. So we get the next row and column based on the direction we're heading, and then we try and go in that direction, and we check if we've exited the map yet. And we also check if the next row or column is a blockage, then we want to change the direction. So go clockwise. You can see these directions are just defined here. And then, yeah, you can see that whenever we get to a square, we mark it as -1 to show that we visited it before. And then at the end, we just count how many -1 squares there are. Then in part 2, they say you can add in one obstacle, and then by adding in an obstacle, you want to try and get the guy that's doing this maze to go in a loop forever. So my intuition here was, okay, so we know we're following this path, right? And the path would be all the squares that I called -1 in the initial. In this code, all these squares that I marked it as -1, which are the squares we visited, are the only squares it's possible for the guy to initially traverse. So when we're putting an obstacle, we have to put it in one of these known spots. And then my idea was, let's just do a brute force. We'll try put an obstacle in every one of these known spots. And then if we put an obstacle in one of all the spots he's visited before, will he get stuck in a loop or not? So all these potential coordinates, so these are all the -1 values we got from part 1. And I just stored them in this potential coordinates value. See, whenever it's -1, we add those row and column. And then my idea was, I'll keep this vector of bins. So yeah, 3D array. And what this is it's pretty much the initial map, this map here, but we also keep one for every direction. And my logic is, if we ever reach the same square twice, going the same direction, that means we're stuck in a loop. Yeah, so I kept 4 for every direction. You can see for every direction, I added a 2D array, and I set the obstacle in there. So essentially, I have a 3D array that keeps track of where we visited and what direction we were facing when we visited that square. So that if we ever go back to a square we've already visited, we know we're stuck in a loop. Oh, also there was one more edge case that really got me caught up, and I had to actually saw something online about it. So the edge case that really messed me up was this one here. So say we're here and we're going to the right. So in my initial code, it says, oh, we've detected that there's a collision ahead, so we'll rotate the direction and keep going. So then what happened was I'd end up like this, and I would have like overwritten a blockage. So I had to add some special code which says, if I encounter an obstacle, we keep turning until there's not an obstacle on our path. So that's what this while loop here does. It just says we keep checking the next direction, and if there's an obstacle in the way, we just keep rotating through. Anyway, that's it. Thanks for watching. Yeah, so I